Welcome everyone, my name is Bogumił Kamiński and today I will give you a presentation about release management process that we use in data frames JL and JuliaData ecosystem in general. So let me start with some thoughts about things I need to do as a data frames JL maintainer. So one kind of things are exciting, like, developing new algorithms, new functionalities, like, for example, a recent addition of a fast group by algorithm for integers by Milan. But on the other hand, you have many things like users coming to you and telling you that things that should work because they were posted on Stack Overflow do not work, and what to do with this. And fixing such things is probably less exciting, but no less important. Why? Because not doing this boring stuff, so not doing the package maintenance things, actually will make people leave your package. And what is worse, usually silently leave. So they will not tell you they don't like your package, they will just stop using it. Of course, doing exciting stuff is very rewarding because of such things people love your package, but still doing the boring stuff is really important. Fortunately, I have learned that most of the issues related with this boring stuff are coming from how we manage the release process of data frames JL. And today in my talk, I will spend some time explaining you how we approach this. So let me start with highlighting that this talk is both for just regular Julia users, but also for package maintainers. So I have indicated the green part for the regular Julia users. So even if you do not plan to create your own package, probably you might be interested in this stuff. And if you have your own packages that you want to manage, then I recommend you to also listen to the blue part. Of course, if you don't want to create your package, of course, I also invite you to listen to the blue part, because maybe you will better understand the pains that maintainers of the packages go through. So let me start with the green part. And the green part refers to a very simple question. A user wants to install data frames JL. The user knows that they want some specific version of this package, but they are unable to install it. And this is one of the most common questions Julia users ask. How to install the package in the latest version? And in order to understand why those problems appear, we need to know that every package has a file that is called a project toml, and within this file, as you can see here, there are exact specifications of the versions of other packages that my package depends on that are required in order for it to work properly. So here you have an example of project toml of data frames JL, and for example, we can see that pulled arrays need to be in the version at least 1.2.1 for data frames JL to work properly. So why it's so important? Well, it is important because if I release some package, for example, data frames JL, call it my package, I need to be sure that any dependency of this package will work correctly with my package. This means that I need to specify a lower and upper bound on the version of this dependency package that I know will work correctly with my package. Here is a small warning. This lower and upper bound is something that should be done, but in the past, many packages only specified a lower bound for the version of the package dependency that is allowed. And why it's a problem, I will show you in a second. But what are the consequences of the fact that every package has some lower and upper bound in a proper, if properly managed? So the problem is the following. If I want to install the latest version of my package, the packages that you already have installed might require either older version of my package or older versions of the dependencies of this package. So if this is the case, what can happen? Either you cannot install your package at all because there is a version conflict, or you might install a version of your package but at some very old version. A version that, for example, didn't have this upper bound on the dependency version. See the warning above. So let us see it in practice. I ran it on June 24th, 2021. So I have a clean project environment, as you can see, and install data frames and pooled arrays. And after adding data frames and pooled arrays, I check a status and I have data frames in version 1.1.1 and pooled arrays in version 1.2.1. Now, if I want to add JuliaDB to the same environment, I can see that data frames and pooled arrays get downgraded. Not only those packages got downgraded, but also some other packages that are recursively required, like compat, data structures, missings, were also downgraded. Why did it happen? Well, in order to understand why it happened, let us try forcing installation of data frames in version 1.1.1 that I already originally had. And what I learned? I learned that I cannot do it because pooled arrays, pooled arrays is a common dependency of data frames and JuliaDB, and JuliaDB does not allow the version of the pooled arrays that data frames 1.1.1 requires. So that's why I get an error. I understand why I get an error, and what do I do then? Well, then I open an issue in JuliaDB in order to synchronize it. So as you can see, here is the issue opened that JuliaDB should have a new release that because the current release holds back the pooled arrays to a very old version. Okay, so this is of course something we can and should do, but what are the lessons from what we have seen in summary? So first of all, for the users, always check status of your environment that you are currently working in to make sure that the packages are in versions that you expect them to have. Then the second lesson is use per project environment. So this means that I can perfectly well have installed data frames JL in one project in the latest version and in another project JuliaDB in the latest version. The only problem is when I try to put those two packages in the same project, but hopefully it comes less frequently. So using per project environments reduces the risk of clash of versions of the packages. Finally, if you don't know what holds back the installation of the correct version of the package, just try adding it at required version and learn what's holding it back. Now, the question is what package managers or maintainers should do in order to reduce such problems. So first of all, we usually try to have as few dependencies as possible. And one of the ways to handle this is by using interface packages that I will talk about in the second part of my talk. The second thing is that if we know that some packages are tightly coupled, we should synchronize their releases. So this means that if I release, for example, pooled arrays JL, then I know that I should also make a release of data frames JL to allow the latest version of pooled arrays JL. Finally, it's very important not to make breaking releases too often. Why? Because making any breaking release usually will add tons of work for packages that use the package you maintain and usually it takes at least 1 month, for example, in DataFrames.jl to synchronize everything correctly. Now, before I move forward, let's have a look at the common pitfall. So, for example, here, I have a DataFrames, JuliaDB, and pooled arrays project that I have shown you, and I try to use categorical arrays, and this works. You might be surprised. Why does it work? I do not have categorical arrays installed in this project. Well, it works because Julia looks up not only the current project environment, but also global project environment when looking for packages. So if it does not find the package in the current project environment, it tries a global project environment. Why is it a problem? Well, let's see. I try the following scenario. In the global project environment, I have installed the latest version of DataFrames. But now I create a local project environment from scratch, add only JuliaDB. I know that JuliaDB is conflicting with DataFrames, so I have added JuliaDB. I could not add, as we have seen, DataFrames.jl in version 1.1.1, but I can have it installed in my global project environment. So using DataFrames will work. So I can execute this command, but the problem is that I will get an error that the compilation fails. Because of this, maybe let's go back here for a second. So this compilation fails. What does it mean? It means that we have to be super careful not to try loading packages that are not within my project environment, because then I get such an error and people report on GitHub an issue that the DataFrames has a bug. And actually DataFrames does not have a bug, but there is simply a conflict because local project and the global project versions of the packages that do not work together well. So this sums up this green track that every Julia user is probably should be aware of. Now let's move on to the recommendations for package maintainers. So I will just discuss how we do it in DataFrames.jl. So our basic workflow is as follows. So development takes place in the main branch. If we make a PR, we also merge it into main branch. And of course, if we are ready to make a release, we just make a tag and make a release using a normal process. But what is the challenge? Assume that we in the main branch have some changes that are prepared for 1.2 release, but we find some bug. And this bug needs to be, also, of course, it needs to be in 1.2 release, but we also need to backport it to 1.1 branch. So what do we do? So we merge such a PR into a main branch, but after merging it into a main branch, we also create a patch branch at the 1.1 release tag. Then we cherry pick the commit related to this bug fix. Of course, we need to make sure that this cherry pick does the correct thing. And after the CI passes, we make a release on the bug fix branch. So in this way, we have a 1.1.1 patch release made from a side branch. And on the main branch, we continue developing 1.2 release of the package. Now, what are the practical considerations here? So we only backport bug fixes to the latest release. So we do not have the LTS release like, for example, Julia has, and this simplifies things a lot. The second thing is that in order to keep track what has changed when, we make sure that every change we make lands into new MD file, so that the user can quickly learn what changes we made in what versions of the package. Finally, because DataFrames.jl is already post 1.0 release, this means that actually in the long term, I do not expect adding any breaking things to the package. Of course, at some point we will make a 2.0 release, but not soon, when we will make all the appropriated breaking changes, and in the 1.x releases we will just add depreciations. The hard thing is that sometimes a proposed change is on borderline of being a breaking versus being a bug. And here is an example of issue 2779, which is this kind of issue. I will not go into detail about the issue, but just refer it to you so that you can read the discussion there to learn about such things. So actually, in short, this is a functionality that worked, but and it worked following the description, but actually what it did, it was not something we liked and everyone thought it doesn't make sense. So actually we decided that this is a bug, because it didn't work as intended, although it worked correctly. And we changed it and included it in the 1.x release. So another thing is that GitHub is really useful for managing releases. So first of all, we keep track of milestones. So I always know which things need to go to patch release, which things need to go to the next release, and which things are scheduled for the future but not implemented yet and not decided yet when they should be added. And finally, if I do not set a milestone, it means that we are not sure yet if we want to add this feature at all. And the second thing is labeling things. So the key labels are things that are bugs, that are new features, that are breaking or that require backporting, or things that fail within the continuous integration or changes in the ecosystem that are required to be taken into account in the DataFrames.jl. What is important here is one very simple rule. If someone opens you a PR or an issue, immediately classify it so that you can keep track of it. Because in, for example, DataFrames.jl, we have over 100 issues and PRs. Without immediate classification, very soon it would not be able to manage it. We would not know which things are working, which things are not working, what should be the priority. And using milestones and labels, really, we can very easily filter out things that need to be taken care of. And probably here I am speaking about things that are pretty standard, but I think that those standard practices really help us a lot, so I thought to share them. Finally, I have mentioned earlier that we need to coordinate releases of the packages. So for example, let's go back to the project TOM compat of DataFrames.jl. And here is a part of it. And what is important to see here? Some of the packages like Data API, Pooled Arrays, or Tables are something that I call within the data ecosystem packages. So here we coordinate the package releases sequentially. So for example, if I release Data API, then I know I need to release the data frames to also allow a proper version of Data API. Or if I release Tables.jl, I check if I have to make a patch release of DataFrames.jl, because I know that I manage both packages and need to coordinate. However, there are also packages we depend on that are outside of the ecosystem. For example, sorting algorithms. Very useful package, but this is not a JuliaData ecosystem package. And notice what is the difference here. Here, usually, we are more flexible with the allowed version of the package, because probably we do not use the latest features of those packages, but simply at some place of the package, we use some specific feature of this package. This means that we just need to make sure that we allow every version of this package that has this feature and works properly. So why these more flexible version bounds are useful, you already know from the green thread. Because if you are more flexible with version bounds, there is less risk that we will have a package version conflict when installing several different packages to our project. So this flexible version bound management is really something that simplifies life of our users. So the last thing is interface packages. So in JuliaData ecosystem, we have two major interface packages. Those are Data API JL and Table JL. And let me comment as a last part of my talk why such interface packages are useful. So first of all, we have less dependencies, and you already know why it's important. For example, data frames does not depend on categorical arrays. And it was a long requested feature. And now we do not depend on it. Why? Because we use categorical arrays fully via Data API JL interfaces. This also helps us reduce the code duplication. Finally, other things are that if several packages want to use the same name of some function, like transform and predict, those are my favorite because everyone wants to transform things and predict things. So you put such functions in API package and you are sure that you will have less problems with exporting them, which reduces type piracy issues, but also helps on agreeing for the common API contract for the functions across different packages. And finally, those interface packages, because they do not do implementation but rather focus only on the interface, they have less frequent releases, which, as you have seen, greatly simplifies package maintenance. So what are the conclusions? As you have seen, proper maintenance of packages like DataFrames.jl really requires taking into account many factors simultaneously, and I must tell you that it's not that as easy as I initially thought it would be. Also, what is important, that it's a social process. So the hardest things we have are things that are subjective, like for example function naming. So we have said that we need to monitor dependencies and their versions, and here Compat Helper is a super useful package, and you should enable integration with Compat Helper in your project for sure. Finally, it's very important to have continuous integration set up for Julia nightly, because even minor releases of Julia tend to break things in the packages. And finally, all this would not be possible without two things. First of all, having clear contracts for every functionality you provide, and this is what we do in the documentation. And the second thing, an extensive test coverage, because you want to be sure that if your dependency changes and breaks something, that your tests will catch this. So really, writing down contracts for functionality you provide and having a very good test coverage is something that saved us many times in DataFrames.jl. So to conclude, let me show you this thing. Going back to the boring stuff, yes, I know that many of those things are boring, but when we start developing a package, we become responsible for it. So also those boring things are super important, and I am always happy to do them because I know that they are helping people.